Hi, WHAD here, recording on April 12th, 2026. This is going to be my fourth video based on the ICOM IC705 interface to the Xiegu XPA125B linear amplifier for remote band switching over Bluetooth. Let's take a look at my setup in operation so you'll know what we're going to be talking about here today. Here we go. So here's a little trick I learned today. I was having a heck of a time seeing the XPA125B display on this camera. Check this out. I'll just go ahead and stick that right on there. Yeah, that's gonna work. This will be my setup today. My ICOM 705, XPA125B linear amplifier, my MFJ 267, and then here is the converter that I built. This is all hooked to a 20 amp hour lithium battery, and I'll be using the IC705 totally on its own today on the internal battery. So let's get it fired up here. Turn on the Xiegu, that fires up my unit. Initially, you get this splash screen, and then when you turn on the ICOM, you'll see here quickly it'll show a Bluetooth connection right there. So it's now connected. Notice that as soon as I start tuning, the splash screen will disappear on my unit and just start repeating. So this is the working screen. You'll see the frequency. The second line is the band and the output voltage that the Xiegu wants for that band. And then my digital analog converter, I put a correction voltage in the sketch. In order to get that 2.3 volts on the second line exactly, I had to put 2.36 in the sketch. So that's basically a slight correction to get that 2.3. That's just due to the DAC inside of this unit. They're all going to be a little bit different. You do not need to do that. The voltage is set right to the factory. Settings are fine. I just got a little crazy, did that, and displayed it on the screens. Okay, here's a quick view of the thing in operation. We're on 40 meters. I've got the amplifier turned off right now. When I key the amplifier, I'm just using the internal dummy load, and I get about 2 watts. I'm only hitting it with 25%, so this works fine on just battery power from this thing, even at 25%. If I turn the amplifier on 40 meters, 94 watts. It's showing about 100, so yeah, we'll just do a couple other ones here. Let's try 20 meters. 106 watts with 2.1 watts in, so it doesn't take much to drive these. I think here with that much, I'm probably going to have to come back a little bit because it's going to overdrive. We're about 15%. Let's see, 15 meters. Yeah, 100 watts. Select your band. You're up and running. So yep, it's working out pretty good. This is my build. I bought these little enclosures off of Amazon, super inexpensive. Put some little rubber sticky feet on there just for good measure. These open up simply by putting them open with a screwdriver. And here's the unit. Let me set this down. This is the ESP32 module here. The display board you can see down in there. There's my little perf board there. This is the 12 volt 7805 12 volt to 5 volt converter. That little square chip there is the optocoupler. This is just a generic 20, I think it's 2 and 22. Any NPN transistor would work. A couple of bias resistors. You'll see those in the schematic. This really worked out well. I would not recommend building this thing in this small of a case. It made it a lot more difficult. Also, I added this toroid here. It's just a generic suppression toroid. I wrapped as many turns as I could on the input and output around it. Just any stray RF or anything, it should help take it off of there. Not necessary. I had it, I put it in. So came out nice and small. And that's my go-to unit. That's what I'm using right now. Okay, here's the schematic of this module. This is my latest schematic. You can download the schematic from my GitHub page, JimD 2002. And there's a couple of versions of the schematic. This is the latest one. I would highly recommend using this one. It's pretty simple to build up. Either one will work. Just has a little more safety built in. Okay, so this is the 6-pin mini DIN plug on the back of the XBA125B. We pick up 12 volts from pin 1. We run it through a 0.5 amp fuse for protection. Feed it to basically a 12 volt bus bar here. If we go to the right, we feed it to an LM7805 12 to 5 volt converter, which powers the ESP32 module. The ESP32 module communicates to the IC705 via Bluetooth for its frequency information. It parses out the data and feeds it out through its internal D to A converter on pin D25 here back to pin 3 of the XBA125B. Also, we have here a 128 by 64 display that runs off of the internal I2C port. The display is not necessary, but kind of handy to have. We go to the right here, the 12 volts runs this opto-isolator keying circuit. This is the 3.5 millimeter jack on the IC705. When you key the transmitter, the tip goes to ground, thereby grounding pin 2, turns on this internal LED, turns on this opto-isolator transistor, which turns on this transistor, pulling this collector to ground, thereby keying the key circuit on pin 2. So yeah, that's just a quick explanation. This parts list is just a recommended parts list. It's not, most of these parts are not very critical. This transistor can be just about any NPN. Oh, a note up here, I did not put any heatsink on this 7805. The ESP32 module only draws about, I think a max about 300 milliamps. I didn't see any issue there at all. So that's the schematic in a nutshell. If you have any questions, don't be afraid to leave comments. I'm not going to get into the programming of this module with my sketch because that's covered in a previous video, which I'll leave a link to at the end of this video. I hope this video was helpful. Don't be afraid to leave a comment if you have any questions. I do check my comments pretty much every day. So for now, this is W8JD saying 73s.